So this video real quick takes a look at the 22 over 7 pi, and it derives the square root of 2, which we currently have based on functions that were given in our calculator, and some other weird ways that really don't give us a clear understanding, both geometrically with numbers in harmony. It kind of has the same problems as our current version of pi does. But I've shown you, for example, square roots of 2. None of these that you're seeing right here, none of this is using any irrational numbers at all. We're using pi increments to come up with our versions of pi, which gives us the geometry of the Earth. And to get our square root values, square root of 2 of 1260 is 1782, and this is derived from taking this number here and decreasing it by 10%, and that actually gives us a square root of 2 of this value multiplied times the square root of 2, which gives us 1782, and all these remain integers. Okay, so I'm going to show you how it can be derived, and then I can show you that it is just as close to the original version that they give you on your calculator, up to 8 digits after the decimal place. And that's using their version. However, I think their version is a little bit flawed. But for example, here's a calculation right here showing you just how close it actually is. So I'm going to show you how that's derived real quick. So you've seen how I've gotten 1 radian, worked my way backwards and all that stuff. Let's take a look at deriving the square root of 2. So if we take pi, which is as 22 over 7, and then we take it, divide it by 2, and we get this value here, which is pi over 2. If we take the reciprocal of pi over 2, then we get 636363. So let's just do that real quick. So let's take 22 divided by 7. We'll divide that by 2 and take the reciprocal, and you notice we get 0.636363, right? So if we take this number right here, which is our pi over 2, the reciprocal of that, and we increase it by 10%. So I'm going to divide by 0.9. And then I get this number, 0.70707 continual, right? So if I take that number and I multiply it times 2, then I get this one version of the square root of 2 that I've shown you before. The other way to do this, which is slightly different, is to take our pi over 2 value. So we'll take 22 divided by 7, divide by 2, and now we're going to decrease this by 10%. So we're going to multiply it times 0.9, and you notice we get a 1.42857, which is the sevenths, right? Okay, so let's take that number, and we're going to clear the memory and add it, and then we're going to grab our other one. So we're going to take the 22 divided by 7, divide by 2, take the reciprocal, and then we're going to divide by 0.9, which means we're going to increase it by 10%, and then we're going to multiply times 2. And then we're going to take the average of this and the other one. Okay, so we're going to take this one and we're going to add it to the other one, and then we're going to divide by 2. And this number that you see right here is very close to what they give you on your function for the square root of 2. And you've actually seen how we've derived it using very simple means, right? We've increased things by 10%. We've decreased them by 10%. If there's anything the pyramids have shown me, it's shown me that anything outside of that square of the pyramid represents a value above 1, and inside the pyramid represents its reciprocal. And that's what Khafre is actually showing us. And that's the reason why the side length of Khafre is 707.1067 feet. Because it is showing us that particular thing. It is showing it as it's a reciprocal. Because if we take the square root of 2 of that, it's actually 1,000. So if we take this number here and we divide it by what we actually get as a function of the square root of 2 on our calculators, this is how close we are. 1, 2, 3, 4, 5, 6, 7, 8 decimal places. The difference here is that you can actually see what I've done here. And you can see what I've done by very simple means using the 22/7 system. With what they're doing, they're not showing you the same thing. So if we come over here and we take a look at how this kind of works up here, if we take a look at the way the pyramids are, because the pyramids, both side links of both the Great Pyramid and Khafre, they both are 7s. So the 756 represents the 7 of the system. We can see that by its factors as well. And the 1188 represents the 11 of the system. So if we take 1188, and we know this because we can do this real quick, just to show you. So if we take 54 as our pi increment, we can see that 756 is the 7 using 108, and on the 11 it's 1188. Okay, so we don't need to use any kind of pi or anything like that in order to figure this out. And we can see that the square root of 2 of 378 is 534.6. The square root of 2 of 756 is 1069.2. Only by decreasing or increasing. So 756 is actually equal to 1188 divided by 11/7, which is pi over 2. This is the number we get. So if we divide 1188 by the square root of 2, which is the same as pi over 2 decreased by 10%, or multiplied times 90%, then we get this version of the square root of 2 right here. So if we take 1188 and we divide by that number, we get 840 exactly. And so the square root of 2, or the 1188 number divided by the square root of 2, is 840. And if you take a look up here, it's actually 840. If you take a look at this circle here, it's 1188. So you can see the geometry matches up just perfectly. 756 right here. If we take 756 and we multiply that times or divide by 0.9 or multiply to where we get 10% increase, we get the 840, which is what I'm showing right here. So there is the square root of 2 derived within 8 decimal places using the 22/7, but actually showing you visual geometric proof. And so this is another reason to use this. We can see that the integers are what are coming out and not numbers that are going on with run-on numbers like noise to the millionth digit. We actually get a clean number system out of this, and it works, and it's visual, and it stays in harmony with everything that we see. So you guys take care, and I'll talk to you soon.